Hello everyone. Today we'll solve problem C from AtCoder regular contest 109. Let us understand the problem statement first. We have three tools, rock, paper and scissors, and we want to decide which one of them is strongest. For this we'll conduct a tournament among 2 to the power k participants. And the number is given from 0 till 2 to the power k minus 1. Let us draw this part on the whiteboard. So for our example, we will take k as 3. So the total number of participants will be 2 to the power k, which is equal to 8 for our example. So I'll draw 8 boxes. This is for first player, this is for second, and so on. 6 and 8. The next two lines is providing a way to find the tool each player has. For this we are given a string s of length n, and that string will consist of R, P or S, rock, paper or scissors. So let us take a string of length 3 and string as paper, scissors and say rock. Now using this string we will decide what tool each player has. So ith player has I modulus n plus 1. And that is simply repeating this string when you reach the end. So the first player has tool P, the next has tool S, then R, then again we'll start from P. The fourth player has tool P, then S, then R, then again P, then S. Now there are no players left. So using that string, we will populate or we will figure out what tool each player has. Now we know that. And the next part in this problem statement will tell you how to figure out the winner of or the powerful tool among all. So this algorithm suggests that I will explain on the same diagram itself. So that algorithm suggests conduct a tournament between the first half, which is P, S, R and P, and conduct a tournament between the other half, which is S, R, P and S. And figure out the winner from each side. So from here we'll get some winner, from here we'll get some winner, and after this we'll have two players, winner of this side, winner of this side, and from them we'll decide which will be the winner. And to decide that, we will simply use this rule, that if there is tournament between rock and scissors, rock will win. In this case paper will win, in this case scissor will win. And if both of them are same, so you can take any one of them. So for example, so say winner from this side is rock and winner from this side is also rock. So the winner of these two will be rock. It is mentioned here. If you see, if the match is drawn, you can take the any one of them because both of them are same. It doesn't matter. Okay, now you know how to decide between two. But who will be the winner of these when the tournament will happen between these four? So we have to repeat the same thing. Again, we'll divide it into two parts. So left hand side will be PS, right hand side will be RP. From here, left hand side will be SR, right hand side will be PS. And for this also, we'll do the same thing. This will be P, this will be S, R, this will be P, this will be S, this will be R. Now I'll quickly do this. P, then we have S, R, P, S, R, and PS. Okay, now we can't divide further, right? So there is single player here, which is tool P. So winner will be P only because there is single player. And here it is S, right? But who will be the winner among P and S? Paper or scissor? For that you can use this paper and scissor. Scissor will be the winner. So here you get scissor. Similarly, you can fill these two. Here will be rock, here will be paper, and rock and paper. Paper will be winner. Then similarly from scissor and paper, you can decide scissor will be winner. And you can repeat this process. Scissor and rock, rock. Paper and scissor, scissor. Rock and scissor, rock. Scissor and rock, rock. So the strongest tool for this example is rock. So we'll output rock. We'll output R. Okay. So we have this way to solve the problem. So let us try to implement this part or this approach to solve this problem. Then later on we'll see if there is any issue with this approach or not. So how can we implement this? So in order to represent any block, right? For example, say this block, just for example. So for this, if you notice, you only need two things, right? Size of this block and the starting point, this S. Okay, so you will go to the string. This S will be a part of this string, right? And you know which position of this string came here. So for this example, this is 0, 1, 2, and you are repeating this 0, 1, 2, then 0, 1. So this is 1. just the static and the length. Length is here 1, 2, 3 and 4. So instead of 4 you can write 4 here, or you can write, since every block will be a power of 2, you can write just the power. So it is starting from 1 of this string and it has length 2 to the power 2, which is 4. So if you start from S, so you start from say S and length is 4, S, then R, then P and then S, you will get this block, right? So this 2 is sufficient to represent any block. Let us try this block. What will be the representation for this block? You can pause the video and try to figure it out, and then you can match. So this is position 2. So it will start from the position 2 in this string and it will have length 2, but we are just using the power. So 2 to the power 1 will be 2, which is the length of this block. Correct? Yes. So now we know how to represent each block using a pair of numbers. So what we want? We want the answer for this, for the first one, which is 0 and 3, right? Or you can say in general it will be 0 or k. So we want the answer for 0 comma k. Correct? Okay, so we can start the coding part now. I will keep the figure on the left hand side. So let's start. So we have 3 things as input, right? Length of the string and k, that is 2 to the power k participants, and the string itself. And we know that each block can be represented by a pair. So we want to find the answer for this 0 comma k, which is the first block. So you want the answer for this block, right? This first block. So it was 0 comma k. So we'll just print this and we are done. And you can, let's keep this outside so that other functions can access as well. Okay. So we have to implement this method. See, find answer 0 comma k. So it will return a character, which is the strongest, rock, paper, or scissor. Method, it has to the start index in the string and k, and we will do to let us use I and j. So this is the first part and j is the second part. So how many elements will be there, you can say 2 to the power j. Okay, now what we have to do, we have to split them into two part. So you are here, starting point here is I, number of elements are 2 to the power j. So when you divide this into two part, right, so each will have half size, correct? 2 to the power j minus 1, 2 to the power j minus 1. And starting point, let's talk about the starting point. And the starting point for this left half will be the same as before. This one is I, this one will be I, right? We have to decide this one. So how can we decide? Simple, we just have to, so this is I, then we will go to, from I, then we will go to I plus 1, then we will go to I plus 2, sometimes we will reach say n minus 1, then after n minus 1 again we will start from 0, then 1, then 2, like this. Because this index is nothing but index from the string. Let me explain with the help of string. So say your string is this, rock, paper, paper. Let's take the same example, PSR. PSR, right? And say your I is here. Now I'm telling you to move how many steps you want to reach here, right? You want to find out this one. So for that, how many steps you need to move? 2 to the power j minus 1, correct? So 2 to the power j minus 1. So from here you will start, you will go to R. Then when you reach the end, you will come to the beginning. Then, so it will, you can simply say it will be I to the I plus 2 to the power j minus 1 modulus n. So this will be the starting point for the second half. Now you know pair for each block. For the first, starting point is I and the j minus to the power j minus 1 size, or we can use just j minus 1 to represent. For the right hand side, the starting point we'll have to calculate because it won't be I. It will, when you move like this, it will change. So you will have to add just how many times you want to move. And since after reaching end you have to come back again, that's why you are doing the modulus n. Okay, and the size you already know, fine. So we have to recursively call find answer. So for the left part, starting point is I, and what is 2 to the power j minus 1. So we'll get left winner, right? Similarly, we'll figure out who is the right winner. This part will be j minus 1, correct? Because the size of both are same, but you have to figure out the starting point. So the starting point is this I plus 2 to the power j minus 1. Let's calculate here. Start of second block, which is I plus 2 to the power j minus 1. So in C++ you can simply do this. So this will give you 2 to the power j minus 1. So after addition, you can do modulus n, correct? So now you know the starting point of the second half. You can pass this start of the second block. Now you know the winner of the left side and the right side. Can you decide who will be the winner among these two, left and right? So you can write a function to decide the winner among left winner and right winner, right? And whosoever is winner among these two will be the overall winner. So it will take left winner and one will be right winner, and it will return winner among these two. Okay. And if both are same, right? Say both are rock or both are paper or both are scissor, in that case you can return any one of them. Otherwise, so left hand side is say rock, and you'll have to write all the cases, and right one is paper. Okay, in this case you will return left one, it is rock. If left one is paper and right one is rock, so you will so among these two paper will be winner. And similarly you can write this is scissor and this is paper, so here scissor will be winner, so simply return LW because this is here. In other cases it will be the second will be winner, second block will be the second will be winner. So when they are same, return anything, and in these scenarios this will be winner. If none of them hold, then the right one will be winner. This is simple, this you can figure it out. Now you know this also. One more thing is left. You need to put the base condition here, otherwise it will go into infinite loop, right? It's simple. When j equal to 0, because so your base case will come from here last, right? Here. So here size is 1, the power will be 0, 2 to the power 0, right? So in that, if the size is 1, so you can return that same character, that is ith character only. That is S of I, correct? Yeah, let us see whether it is working fine or not. Let us take the same example. We have n is 3, k is 3, and PSR, and the winner is S. PSR. This approach is saying the winner should be scissor, but we have figured out that the winner is rock. Something is incorrect. Let us figure it out. Have we made any mistake either while doing this or either in the code? So PSR, PSR, PS, PSR, PSR, PS, PSR, PS, PSR, PSR, PS. Either correct. Paper and scissor. Scissor will be winner. rock and paper, paper will be winner. Scissor and paper, scissor will be winner. Scissor and rock, rock. Paper and scissor, scissor. Rock and scissor, rock. Rock and scissor, rock. No, it means there is some issue in the code, right? Seems like the answer should be rock only for this example. So n is 3, k is 3, string is PSR. We want to find starting 2 to the power k players. Correct. If j is 0, means size is 1. So we can return s of I. Otherwise, we'll figure out left winner by this I and j minus 1, and right winner by starting point and j minus 1. The starting point will be I plus 2 to the power j minus 1. Modulus n. Oh, here it is incorrect. This method is incorrect. Here is rock and here it is paper. So out of rock and paper, paper should be winner, right? And we have already taken this paper and rock into account. So this is wrong. Paper, rock, rock, paper. There should be rock and scissor. Rock and scissor, then rock will win. Paper and rock. Paper will win, scissor and paper, scissor. Now it is fine. This here was the mistake. And this is these three statements are nothing. I am just writing these three things there, and I made a mistake. Now let us try run this 3 PSR R, correct, which is correct, which is same as this. Okay, we have. So is there any issue with this approach? Is this going to work for all the cases? You can pause the video, you can think about it and let me know. Okay, let us continue our discussion on whether it is going to work for all the test cases or not. So I have copied one sample test case from AtCoder. Let us try to run this. Length of the string is 11 and case 1. Answer is P and P was expected, which is correct. Okay, now I don't know the answer for this test case, which I'm going to try. So here the string is same. Now I've changed k to 80. K can be 80, right? K can be till 100. You can see in the example constraint. So it is fine. Now let us try to run this. 11, 80, and then this string. Wow. So now seems like it is taking forever to complete. Let us see why it is not working for k is equal to 80. why this approach is not working. So when k is 80, right? So whatever is the case, so how many elements, how many block is there in the first row? First row. Or we can side by side see this example as well. Here there is only one, right? In the next one we have two. The next one we have 1 2 3 4 blocks. So every time it is being multiplied by 2, then 8, right? 2 to the power 0, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, and in the last here 2 to the power 3, right? When k was 3, and in general it will go till 2 to the power k, right? So these many blocks are there in total, and if you will add all of them together, okay, it will be approximately 2 to the power k. And k is, since k is can go till 100, so 2 to the power 100, which is very big, very big, yeah. So that is why it will not run for bigger k, the approach that we have, the code that we have written here, it will not run for bigger k. Let us check whether it's still running or not. See, it is still running. Okay, but instead of this, now let us try smaller k. See, it is working, right? For 20 it is working. Maybe let us try for 25. 25 it is working, right? So for smaller k it is working, but for bigger k, because 2 to the power 25 is still okay. 2 to the power 25 is 10 to the power 8, around 10 to the power 8, so which is okay. But okay, let us figure it out how we can solve for all the values of k. So one more thing to notice here is, as we saw in the code or here, that each block can be represented by this, the index in the string and the power of the k, sorry, yeah, power, 2 to the power. What is 2 to the power? So how many unique pairs can exist, right? So if you look at this first parameter, let us look at the first parameter. So we know that there are two parameters, right? Two parameters. So what is the value the first parameter can take? This is coming from the string, right? This is nothing but some index in the string. So it can have value 0, it means first index, 1, second, 2, 3, 4, like 0 till n minus 1, anything. So there are total n possible values it can take. And what about this one? 2 to the power 2 to the power. So if you notice, the first one is the biggest, which is 2 to the power k, and next one is 2 to the power k minus 1. This is size is 2 to the power k, then this size is 2 to the power k minus 1, then till 2 to the power 0. So notice what is the value possible here? K minus 1 dot 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 is 0, nothing else, right? And here you have value possible 0, 1, 2 dot 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 n minus 1. So here n possible values, here k plus 1 possible values. So overall, how many possible combination, how many possible pair can exist? Distinct pair, around n into k, right? So n is if you look at the test cases, it is 100, k is also 100, so it is 10 to the power 4. Wow. So what does this mean? 10 to the power only 10 to the power 4 states. So it means that when k is bigger, so we have lot of repetition of blocks. Same block is repeating multiple times. So why to calculate every time? Why not to store for the first time and then use it other time, next time, whenever it is required? So if you look at this, for example, if you look at this, since this is a small, this is for small k, there is very less repetition. If you see here, if you look at this, let me use different color. If you look at this one, PS here, and if you look at here, P and S, right? So if you see, this is repeated. So when you calculate it for the first time, say here, so when you reach the second time here, why to go below? We already know the answer for this state, right? So this way, when the k will be very last, there will be a lot of repetition, and you don't want to compute the same thing again. Instead, if it is calculated once, so when the next time the same thing, the same kind of block is encountered, you will see, basically you use the stored result. Understood? Let us take one example to understand it better. How there can, let us say, for example, say string is r. There is a string of length 1, which is r, and say k is 3. Okay, so you will have r, how many times? 8 times. It will be the first block, the biggest block. Then you will have r 4 times, right? Then here we will have r, then again r. So let us look at this part only. So if you see, this and this are repeated, these all 4 are same. So since if these 2 are repeated, I will calculate only once, and when I will reach here, I want to go below. Instead, I will use whatever I have calculated here, right? And when I go reach here, I will do the calculation. But when I will reach here, I won't do the calculation. I will refer this, and I won't ever reach here. I won't even come here because I will stop at this stage only. At this stage only, I won't come here, right? So this way you will see, avoiding the same computation and again. You can do this in, if you see here, only 10 to the power 4 states are there, right? So let us see what we can do now. So if you look at this, find answer. So it requires 2 things, I and j, and you know that the maximum value of I and j can, what is the maximum value of I? It can be 99, correct? And what is the maximum value of j? That is the power, right? It can go to 100, right? So what you can do, you can create memory. You can create a memory where you will store the result, right? So you will create a memory, and how much size you can take? You can take, for the first one you will need till 99, so you can take 101, for, or 100 is okay, because 100 means 0 to 99. For second one, 0 to 100, fine, right? Now what we can do, we can populate this with empty. So for memory I j, so you can take anything. I'm taking this symbol that this thing has not calculated before. This will denote this. So if the value is this, it means it has not been calculated before. Okay. So now it's simple, very simple. If j is 0, that is fine. There is no computation at all here. But otherwise, what you can do, you can check, is the answer already there for this I comma j? So you can check using this. Remember this, you have created this symbol. It means, so if it is not this, it means the calculation already performed. So what you will do, you will return the stored result. See, hey, so this line is very important. You are not doing same computation again. Right? And here, so whatever the answer, final answer you will get here. So what you will do, store the answer in the memory. Store in memory. So this line, we are storing the result, whatever we have calculated in the memory, and here we are using the previously stored result in the memory, right? So we have added just two lines, these two lines. Right, now let us see, is it working for bigger cases or not? 11, let's take 100. Let us take the same example first. Is it working for the older scenarios or not? Like this 11, 1. For this, the answer should be P. Sorry, what I've done. Yeah, answer should be P. And let us change 1 to 100. I don't know the answer for this, but yeah, at least it should not hang now. Seems like there is some issue because there is no output I can see here. Let us try to figure it out. So we have added this memory here. And this is here power K, and the maximum power it can reach is this 100. So that's why I've created the size 101, and I can go till 99 because the string size can be 100. So 0 till 99, right? 0 till, this is j, 0 till 100. Memory ij, we are marking this that it has not calculated yet, right? And no other change here. Here we are doing saving the result. Oh, sorry, here we are checking if it is already calculated, then return the same thing. Otherwise store in the memory and then return. Let us try with a smaller, maybe 80. I'm trying to figure out, is this some size issue? No. But it is working for smaller cases. Yes. What's wrong? For 50 also it is working. After 50, for 70 it is not working. Why? Let us comment this again. $11. Yeah, now it is infinite loop, which is fine because we are not using the memory. But why with this we are getting their memory ij if it is not equal to this hash? Till 100, I equal to 0, I less than 100, I plus plus, j equal to 0, j less than j plus plus, memory ij equal to this. I'm able to figure out what's going on. Should I increase the size of this? Frankly speaking, I'm not able to figure out what's going wrong. That is why I'm size to see some size issue is there. No, size is not a concern. Still trying to figure it out. Where is the issue? Oh, now I know what is the issue. So if you look at this statement, the issue is in this line. What we are trying to do, we are trying to do 2 to the power j minus 1, right? 2 to the power j minus 1. And since j can be till 100, 2 to the power 100 is some number which neither integer, neither long can store. No one can store this big number. So what we need to do, we have to, so this can be written as, so it can be written as I modulus n, which will be I. So let us calculate this part, this modulus n first outside, right? So what we want, we want to do j minus 1, 2 to the power j minus 1, right? So and we will keep taking the modulus together, correct? So this is power of 2, again 2. So For the first time it will become 2, for next time it will become 2 square, next time 2 to the power 3. So after this it will become 2 to the power j minus 1, right? Now we can use p2 instead of this thing, because it will be between 0 to n minus 1, because I am taking modulus after every operation. So now it will not overflow like it was before, right? So 11, 70, now it will work. It should work for 100 as well now. Okay, so that was not the issue. The size, these were not the issue. I can change it back to 100, 101, 100, 101. The issue was here, overflow. Now let us test again. Fine. Okay, so thank you everyone. I hope you enjoyed this video, and I hope you guys learned something from this video. Thank you for watching.